Before I start talking about the distributive property, let's remember that the commutative property used two things. The associative property used three. The distributive property uses two things but uses two operations. Remember, an expression is variables, numbers, and operations. The distributive property has to do with those operations, and specifically two of them. Two operations, namely addition and multiplication. So let's take a look at an example. 2 times 3 plus 5. Now normally we would just say, oh, this is 2 times 8, or 16. If we distribute the 2, we distribute it to each term in the parentheses. So it would be 2 times 3 plus 2 times 5. So it would look like this. 2 times 3 plus 2 times 5. Or in this case 6 plus 10, or 16. Thank goodness we get the same answer, otherwise there would be something very, very wrong. Now it shows up most when we multiply with variables, something like 2x plus 3. Now, I can't combine the x and the 3 because I don't know what x is. However, we can distribute the 2. 2 times x plus, because there's a plus here, 2 times 3, or in this case 2x plus 6. One thing to note is that both terms in this expression are divisible by 2. In fact, this 2. In general, the distributive property looks like this. A times b plus c is equal to a times b plus a times c. Now, because this is an equation, I can read it from left to right or right to left, which is quite nice, because then I can say a times b plus a times c will also equal a times b plus c. And again, note that both of these terms have a factor of a. In other words, I'm multiplying a, this a. Here's an example where we'll use the distributive property and the concept of like terms. If I had x times 3 plus 7, yes, I would simply say x times 10, right? I'd add the 3 and the 7 right away because they're in parentheses, so I'm going to do that first. And I would multiply by 10. And of course, I'd use the commutative property to change that into 10x. So I know it's 10x. Let's use the distributive property. I'm multiplying by x. I've got two terms here, so I can distribute the x to both of these. So that would be x times 3 plus 7. Using the distributive property will look like 3x. I've already done the commutative part. We do that in our head at this point. Plus 7x. I know it's 10x, so essentially what I'm going to do is just add these coefficients, and I get 10x. This brings us to the idea of like terms. Alright, like terms in algebra means that I can add them. So these are what we would call like terms. I can add them. They're the same thing. Alright, I have 3 pencils plus 7 pencils, 3 oranges plus 7 oranges. Right, if I know what x is, if x equaled 2, then I would put 2 into the first location, I would put 2 into the second location. right? I wouldn't put 2 in one and 4 in the other, right? They're alike. The main thing with like terms, and I'll tell you the definition, is they are terms with the same variable factors. We know what a variable is. We know what a factor is. Something, 6x, well, we know that's 2 times 3 times x. That's completely in prime factorization, right? But when I'm looking for like terms, what I'm really looking at is the variable. Let me give you another example. If I have 6x and 5x, these are like terms. 6x squared and 5x squared, these are also like terms. The variable factors well, let's look at it. For 6x, the variable factor would be x. For 5x, the variable factor would be x. If I factor x squared, I get x times x, right, just by definition. So the variable factor at 6x squared is x times x. Just looking at the variable at 5x squared, I also have x times x. These are the same variable factors. So I could add these two, and I would have 11x squared. 6x plus, I don't want to say plus, I want to say and 3x squared. Well, let's look at their variable factors. X and x times x. These do not look alike at all. This factors into 2 times 3 times x. This factors into 3 times x times x. Has nothing to do with the coefficients, right? Just the variable factors. That's what I'm looking at. If they're the same, I have like terms. If they're different, I don't. Like terms can be added. Or subtracted. It's like having a common denominator in a fraction, right? If I have a common denominator, then I can add or subtract those fractions. If I don't, I have to get one, right? Here, if I have like terms, like in this particular case, I could add these two together. If I don't, I can't do anything with them. I'm going to give you one more example, combining some of these concepts together. Simplify. Simplify is a word that's used with expressions, not with equations. So when you hear the word simplify, think, oh, I've got an expression. All right? No equal sign. So say 2x plus 3y plus 4 times 2x minus y. I'm not going to add any equal signs in here because I don't have an equation, so I don't want to pretend I do. So I'm just going to leave the equal signs out, which is another reason to work vertically so I can see what I'm doing. I don't have like terms. I have an x and a y in the parentheses, in both parentheses, so I can't do anything with those. So we'll distribute 2x plus 2 times 3y plus, this is this plus right here, plus 4 times 2x minus 4 times y. Alright, so we distributed. Now we'll simplify this a bit by performing the multiplication. 2x plus 6y plus 8x minus 4y. And at this point I have 4 terms and I want to see if any of them are like terms. I'll start with x. I just have one x here. Is there another location? Yep, there's one right here. So I can combine those. I can say 2x plus 8x. Those are going to go together. And I'm just for emphasis, I'm going to put a parentheses here. Then I also have a y here, plus 6y. And then I have this minus 4y. So I'll say minus 4y. And those are my y values. All right. These are like terms. I have 2 plus 8 of them. So I have 10 x's. I have 6y, and I'm subtract 4y, so I'm left with 2y. And here's the result simplified. So we started with something that looked a little messy and ended up with something with two terms and much simpler.